Sorry, our video was broken up into two videos here, but let's talk about number 7. You and your friend are playing a board game. Your final score X is 12 points less than your friend's final score. And our friend's final score is right here, or your friend had 195 points. We want to write and solve an equation to find out what your score was. So all you know about your score, which is X, so here's our X. Okay, so your final score is 12 points less than this guy over here. So my score is 12 points less than, remember this changes the order, don't forget that. So that means it's 195 minus 12. So there's our equation. Usually our equations are not fully isolated, but the way this one's worded, it already essentially set it up as our variable isolated. So again, if I'm just translating this like we did on that very first lesson, your score X is 12 points less than, so 12 points, subtracting 12 from my friend's score, which we find out here is 195. Okay, and then really all we have to do on this one is simplify. And if we do this math here, we get 183 points. So write and solve of an equation for your final score. Okay, there it is. All right, let's flip it over. If we feel pretty good about one-step equations with addition and subtraction, which is what we just did, then let's look at what it would be for multiplication and division, because it's going to be really similar. So multiplication property of equality, just like before, multiplying or dividing, both of these essentially state the same thing, that you are welcome to either multiply both sides by the same quantity and the equation or balance is preserved, or you can divide both sides by the same quantity and the equality is preserved. 0 is the exception to that, but there's not really a reason why we would want to use that anyway. Okay, so let's try these. Starting here with number 1. This time we have 7 times q. Remember, when they're next to each other, that's automatically multiplication. So 7 times q equals 35. We want to isolate the variable. So here's q. I want to think about, what did they do to q? Well, they multiplied it by 7. And therefore, I want to do the opposite. I want to reverse that and do the opposite of that. So I'm going to divide by 7, because that's the opposite operation. And if I do it on one side, according to this division property of equality, I would want to also do it on the other side. 7 over 7 cancels. It's just 1q, which is just q. So that cancels that out. That was the whole point. And then on this side, 35 divided by 7 is 5. Okay, and then I should be able to check that if I wanted to. Like, we should be able to rewrite that original one and insert that 5 where the q was. So instead of 7 times q, we could say 7 times 5 equals 35, and kind of confirm, is that true? Well, yeah, it is. 7 times 5 is 35. So we know that it checks out. Okay, that's how you would want to check your work. All right, let's try number 2. It says 4 times b is equal to negative 52. So 4 times b, here's our variable. This is the operation I want to undo and reverse so that I have the variable by itself. So the opposite of multiplying by 4 is dividing by 4. But of course, if I do it on one side, I have to do it on the other. So 4 over 4 cancels. That's just 1, or 1b. And on this side, negative 52 divided by 4. And all I have to do is divide that. Well, a positive divided by a negative stays negative. And 52 divided by 4 is 13. So b is then equal to a negative 13. Okay. On number 3, you've got n divided by negative 2 equals negative 15. This is division now, so I still want to take my variable, identify it, isolate it. There's n. They're dividing by negative 2. The opposite of dividing is to multiply. So I want to multiply on both sides here by a negative 2. That's going to be the opposite, or the inverse. It's going to cancel this out, because when I have a negative 2 on the numerator on the bottom and denominator on the top and bottom, they cancel each other out, very much like these two did over here. So that cancels. It leaves us n by itself. And on the right side, a negative times a negative is a positive, and 15 times 2 is 30. So there it is. So n equals 30. Okay. Now, there's our fractions again. So we'll review how to deal with fractions because there's a nice, easy way to do this in one step. It still can be a one-step equation. On number 4, we have 3 over 7 times m, 3/7 m equals 6. Okay. Now, we want to undo that. And this is technically multiplication. So we would be thinking, well, okay, well, if you multiply by 3/7, then the opposite is to divide by 3/7. And technically, that's not wrong. But here's the deal, right? Just a quick review. That anytime we have, I'm just going to give you a side example, right? Anytime I have some number and I divide by a fraction, we don't ever actually do that. So just a quick review. We don't ever actually divide by fractions. Instead, we multiply by their reciprocals. That's how we handle division of fractions. We don't do it. We instead do sometimes they call it the keep, change, flip, right? We sometimes call it the keep, change, flip. But nonetheless, the idea is we don't ever actually divide. So even though technically I'd be like, oh, I'm going to divide by this fraction, I have to remember, oh yeah, we don't divide by fractions. What we end up doing at that point is multiplying by the reciprocal. So the way I'm going to get rid of this is to multiply both sides by the reciprocal. And by the reciprocal, I mean you're flipping the fraction upside down. So the reciprocal here would be 7 over 3. And I would do that on both sides, okay? And doing so, in this particular case, all of this stuff cancels. So the 3 over 3 cancels, the 7 over 7 cancels. That does effectively still do what we wanted it to do, which was to get rid of the 3/7 on the left side and isolate the variable. So that mission is still accomplished when we multiply by that reciprocal on both sides, and it's done in one step, which is pretty nice. So there it is. And then all I have to do on this side is do that 6 times the 7 over 3, okay? Now remember, for multiplication, I do not need to have a common denominator. This is technically over 1, and that's not a problem. But I don't need a common denominator. I can just multiply straight across without a common denominator. I just do numerator times numerator and denominator times denominator. Or if I'm pretty wise about it, I can even notice that I can cancel or reduce some stuff first. So I notice that 3 goes into itself once and into 6 twice. So I can do a little reducing or simplifying first. And then do 2 times 7 is 14. 1 times 1 is 1. So yeah, m is equal to 14. Okay. All right. How about, let's try number 5. Oh, there's that pi again, but that's okay because that's not a variable. We don't have to worry too much. J is our variable, and they're multiplying it by 6 pi. So the opposite of that is to divide by 6 pi on both sides. Divide by 6 pi. This cancels the 6 and the pi, leaves just j by itself. And on this side, pi over pi is also going to cancel. So in this case, the pi's actually end up canceling out. And then all I have to really evaluate is what is negative 108 divided by 6. So when I divide by 6 pi on both sides, it completely gets rid of the 6 pi here. J comes down. Here, pi divided by pi cancels. That's a common factor. That's like reducing. And then negative 108 divided by 6 happens to be negative 18. So here our answer is j equals negative 18. Okay. All right. Let's try a word problem. On number 6, after a party, you have 2/5 of the brownies that you made left over. There are 16 brownies left. So you have to write and solve an equation. Okay, I should just say an equation to show how many brownies you made for the party. Okay, so essentially, you don't know how many you made. This is our unknowns, right? So how many brownies did you make originally? That's going to be our x. But what we do know is that at the end of the party, 2/5 of that, right? So remember, of is multiplication when we're dealing with fractions. So 2/5 of however many you made are left over, and that result ended up being 16. That's how many are left over. Okay, so there's our equation. So we're trying to find out how much did you originally make if at the end of the party you only had 2/5 of that left, and that was equivalent to 16 brownies. Okay, so there's our equation. And then this is very similar to number 4 up here. We can look at this and say, okay, so we're multiplying by a fraction. I want to do the opposite or the inverse of that. But really, the opposite of multiplying by a fraction isn't so much dividing, but rather multiplying by its reciprocal. So we're going to multiply by the reciprocal fraction on both sides. Okay, and again, that makes all of this cancel out because 2 over 2 cancels, 5 over 5 cancels. Or you could think of it as if you do 5 times 2, you get 10. 2 times 5, you get 10. It's still, you end up with 10 over 10, which still cancels. So however you want to think of it, all of this cancels out. Okay, so that leaves us with x equals, and then all I have to do is evaluate this side. And again, you could multiply this first, or you could reduce. Like up here, I saw I could reduce, and I did that before I multiplied. Your other option, just so you see it here, is multiply first and do 16 times 5, which happens to be 80, and do 1 times 2, which happens to be 2. And then you would have to look at that and say, oh yeah, well, 80 divided by 2, that does simplify to 40. So you must have made 40 brownies. Okay, so show how many brownies you made for the party. You would say you made 40 brownies for the party. Okay, all right. Last couple problems here. Let's take a look at number 7. It says the length of a flag is 1.9 times the width. So again, if we take that and we translate it, it's saying the length of the flag, I'm going to call that L, is equals 1.9 times the width. Okay, so that's essentially the original setup. Sorry, I should have put that there. So the length is 1.9 times the width. What is the width of the flag? Well, if I look here to the picture, I realize, oh, this length here, that's the longer side, is 9.5. So I can plug that in for my length, and now I have enough information to solve for the width. So if I divide both sides by 1.9, I end up with the width equaling 5. So that means that the width of the flag is 5, and this is in feet. Make sure you always have your units. So the width is 5 feet. Okay. Number 8, it says 1/6 of the girls and 2/7 of the boys in a school marching band are in percussion, in the percussion section. The percussion section has 6 girls and 10 boys. So how many students are in the marching band? Okay, so it looks like we have to set up a couple of separate equations here. Let's talk about the girls first. So 1/6 of the girls in marching band, so I'll call that G, are in percussion. And that resulted, percussion has 6 girls. So 1/6 of the number of girls in marching band are in percussion, and that is 6 girls. So however many girls there are in band, 1/6 of that quantity is 6 people. Okay. The other piece of information is 2/7 of the boys in marching band are in percussion, and that's a total of 10 boys. Okay, so G is the number of total girls in the band, and 1/6 of that is how many are in percussion. B is the number of boys in the band, and 2/7 of that are in percussion. Okay, so that I kind of have to solve 2 separate things here to find out how many how many total students are in the band. So again, we're multiplying by fractions, so the inverse or the opposite of that is to multiply by the reciprocal. Here, all of this good stuff cancels, and the number of girls in marching band is, drum roll, 6 times 6, 36. 6 times 1 is 1, so 36 over 1 is just 36. So 36 girls are in band, okay? If we do the same thing here, we multiply both sides by that reciprocal. I should have left myself a little more room, but okay. 7 over 2 and 7 over 2. Here, all of this good stuff cancels. And the number of boys in the band is going to be here, 10 times 7 is 70 over 2. Right? If I do 10 times 7 is 70, 1 times 2 is 2, 70 divided by 2 is 35. So there's 35 boys in band total. So this is how many were in percussion, but this is really what's in the whole marching band. And the question wanted to know how many students. So total, I have to add that 36 and that 35 to find out that the total in band is going to be 71 students. So there are 71 students in the marching band. Okay. All right, let's finish off with some geometry problems that help us, the one-step equations help us solve, and then we're done with the notes. So on number 8, you're looking at two situations where you want to find either the height or the area of the base for each of these solids. Okay, and our formulas are given up here as a reference. This is a rectangular prism. This is the formula here. They tell us that volume is equal to the area of the base times height. And in this particular problem, looks like we're looking for the height because we are given the area of the base, so we're given the big B, and we're given the volume. So I can insert those values here and here, and then solve for the height. Okay, so I know the volume is 1,323 equals, and then I have my base area of 147, and then times the height. So I'm just plugging those, inserting what I know. You always want to plug in all the values you know, and then solve for what you don't know. Okay, so to solve for the height, I'm going to want to do the inverse here. Height is being multiplied by the area of the base, which is 147, so I'll just divide by that on both sides. So there's 147. So that means that our height, when we divide 1,323 divided by 147, you can kind of go off to the side and do your long division, because that one is going to probably, take a little bit extra effort. When you get it all said and done, the height should be 9 centimeters. Okay, so the height is 9 centimeters. And then you could always plug it back in and make sure that it worked. Okay, let's look at the cone. The cone has a different formula, so be careful with that. You have a volume that is always going to be 1/3 the area of the base times height. And in this one, they gave me the height and the volume, and we're looking for the area of the base. So again, we're going to fill in what we know. It tells me here that the volume is 15 pi equals, you have 1/3. We don't know the area of the base, but we do know that the height is 5. Okay? So if I simplify this on the left side, I can say, 1/3 times 5, that's just 5/3, right? So we can multiply that together and write this a little bit more simply on the right. 5 times 1/3, because multiplication is commutative, so I can do the order in any, I can do these in any order. So I can do the 5 times the 1/3 and just write that as 5/3. Okay, this side stays the same. And now that I have this simplified, I can realize, okay, so now if they're multiplying B by 5/3, then to undo that, I'm just going to multiply by the reciprocal of that, which is 3 over 5. And I just want to make sure I do that on both sides. This cancels all this good stuff out. I'm left with that area of the base by itself. Over here, I can do a little reducing because 5 and 15, they reduce down to just 3 over 1. And then all I'm doing is 3 times 3 pi, which is just 9 pi. Okay, so the area of our base here is 9 pi, and don't forget your units, square meters. So that would be our answer there. And you could plug it back in and check. All right, so that's a good little review on just solving one-step equations, doing one single inverse operation, and you're done.